In this video, I'm going to show you how you can use the periodic table in order to determine the electronic configurations of any element. And so one of the ways I show you in my slides that are posted on Blackboard is to use that zigzag rule I call, where you line everything up on the left side and kind of draw all those arrows. But for this one, it's actually a lot easier if you understand how the periodic table is set up. And so by that, what I mean is everything in these first two groups, or group 1 and group 2, the things that come right before everything kind of breaks down into the transition metals. Groups 1 and group 2 are known as the S block. And the reason for that is because in these two groups, you're filling in the S1 and then you're filling in S2. And then if you jump to the other side, again, skip all the transition metals for now. But if you skip over to this other side here, you'll notice that this is what we refer to as the P block. And so in the P block, again, you're going to be looking at all of the groups after the transition metals. And so one thing that you can kind of, I guess, use as a guide is in your S block, you can fill in a maximum of 2 electrons. Remember, there's only one S orbital, and that's all that can ever exist. Because there's only one S orbital, and you can fill in 2 electrons per orbital, that means you can fill in a maximum of only 2 electrons in every S orbital. And the way this works is, as I kind of stated, your S1, again, this is 1s1, this is 2s1, 3s1, 4s1, 5s1, 6s1, 7s1. Same deal applies. For, again, you kind of have to ignore period 1 because it's all kind of goofy. But in period 1, you'd have 1s1 for your hydrogen and 1s2 for the helium. But starting in group 2, or sorry, period 2, things kind of get a little bit less weird. And so here, lithium is going to be a 2s1. Beryllium is going to be a 2s2. But notice here, you skip all the transition metals and you go straight over here into the P block. And now you're looking at 2p1, 2p2, 2p3, 2p4, 2p5, and 2p6. And as I kind of stated, the P blocks, there are 3 orientations. And each of those 3 orbitals can hold a maximum of 2 electrons. So therefore, you should have 1, 2, 3, 4, 5, 6 electrons total that you can fill into the P block. And so now let's go back to the d orbitals, or these transition metals. And so the transition metals are kind of goofy. And the one thing you always have to keep in mind is that they are basically off by 1 period. And what I mean by that is in period 4, you are looking at your 4s1, 4s2, but you are now jumping into the 3d orbitals. And so remember, in the previous video that I posted, I mentioned starting after period 3, you're going to have to start filling in the n-1 d blocks before you fill in the np blocks. And all I mean by that is, as I kind of started showing you here, 4s1, 4s2, then this is going to be 3d1, and then 3d, 2, 3, 4, 5, 6, 7, 8, 9, 10, until you're at 3d10. But remember, whenever you jump out of this transition metal block, or the d orbital block, you're going right back into the p's. But the p block here is still going to be in your n equals 4. And so the way that this works is you always have to remember, if you're going to be looking at this and using this to write down your electronic configurations, you're always going to be looking at an n-1d block in the period. And so this entire row here is going to be your n equals 3d. This is going to be your n equals 4d. This is going to be your n equals 5d, and this is going to be your n equals 6d. And so when you kind of go through these, you have to just remember that this is going to be slightly off in the center here. The S block and the P block, those are fine. Those exist in the periods that they exist in. But the D block is slightly different. So, just for future cases, and again, you're not going to have to know this too much, but you also have to understand that these lanthanides and actinides, the way that these fit, and you'll kind of notice with these number system, these actually kind of fit into this star and the 2-star group here. And so this La is going to be your lanthanide, but then again it jumps into all of these this group here. And the same deal with your actinide is going to jump straight into all of these before it even enters the rest of this D block. And so the way that that works, again, even more confusing than the D block, this is actually n minus 2. And so here you'd actually be looking at the 6s group here. Then you're going to go into the 4f group. Then you're going to pop back out into the 5d. Then you're going to go back into the 6p. And so if this is confusing you, use my little zigzag rule first in order to kind of get the rhythm down. And then this should be slightly less complicated when you try to go through and look at these. So, for example, I'll just choose a random element. Hey, let's talk about lead. And so for lead, please note that lead is going to be in the P block. And so we know once we finish up, hopefully your last letter you write out is going to be P. So the way we can do this is, again, start off at the very beginning and go to your hydrogen. Because remember, hydrogen is the lowest energy level because it's sitting in that 1s1. So here we know we're going to go to 1s1 to 1s2. And then you're going to have your 2s2s and then 2p6. And then 3s2, follow it all the way across to 3p6. Then 4s2, 3d10, and then your 4p6. And then start over your 5s2, then your 4d10, then 5p6. And then 6s2, then we're going to have to go down to our 4f14, then your 5d10, then we're looking at our 6p12. And so, using all that, again, you have the full electronic configuration. If you want to write the shortcut method, life becomes, again, a little less complicated, so you don't actually have to start all the way at the the hydrogen, and you would just start off at the xenon because it's the noble gas that precedes the lead. And so you'd still write xenon in brackets, and after that, still do the same thing. 6s2, 4f14, 5d10, 6p2. So hopefully this kind of clears everything up. And so the only kind of situation that you would probably find yourself in that would kind of be complicated is whenever you start talking about these, what I refer to in my notes as the funky equations or the funky configurations. And so those are always going to be with your chromium, your molybdenum, your copper, your silver, and your gold. Please take a look at my notes in the slides where I kind of talk about those. But that's the only time that using this method is going to be slightly thrown off.